Hi everyone. In today's video, I'm going to talk about the errors that can creep into your hypothesis testing. Under this topic, we will talk about the errors that can creep in due to a faulty research design and talk about the different examples of that. Then I'm going to talk about errors that may creep due to sampling errors, and as well as we'll talk about type 1 and type 2 error in hypothesis testing. So I will also explain what is a null hypothesis and how is a null hypothesis related to type 1 and type 2 errors. So let's get started. So the first kind of errors that can be caused in hypothesis testing can be broadly classified under a faulty research design. Let's discuss some different examples of what is considered a faulty research design, which can then lead into error in hypothesis testing. So the first one is where we have not addressed a particular ethical issue, or you have not identified or minimized risk for the research participants. Let's take an example where you are engaged in a qualitative research study and you, as the interviewer, is also the researcher, but you also have a direct relationship with the participants. An example could be if you are a teacher in a university or a lecturer in a university and you are trying to interview the students on finding out how you can improve educational practices. The students, due to the direct relationship they share with you, may be hesitant to provide you with honest responses. In this case, you should have ideally distanced yourself from the research participants and employed someone else to conduct the interview. Because you did not minimize the risk for the research participants where they are hesitating to provide honest responses, your hypothesis or the testing of it might be at risk. The second type is a sampling bias, where you have selected the participants purely due to ease of access, or what we call is convenience sampling, where you have easy access to the participants. Now, there is nothing wrong with convenience sampling except if that sample is not the appropriate sample for your research question or your hypothesis testing. For example, your hypothesis may require participants from low socio-economic status. Now, because you have access to participants who have unsteady source of income, you tend to interview them instead of people with low socioeconomic status. Now here, the distinguishment between low socioeconomic status and people with unsteady income has to be clearly made. Someone with an unsteady income may still be at a higher socioeconomic status because of the earning they make during their earning period, whereas low socioeconomic status could be someone who makes less than $20,000 a year, something like that as an example. So here, because you have easy access to people with unsteady income, you should not start interviewing them to address your research question, which deals with people of low socioeconomic status. This is where your hypothesis testing will go wrong again. Then you also have to ask yourself, are you using the best research tools or not? Are you using the best research tools, best instruments, or techniques? For example, is a quantitative survey the best way of collecting data or a qualitative survey? If you are using a quantitative survey, has it been tested for validity, reliability? Has it been used before? If it has been used before in other studies, does the validity and reliability still hold true for your own research? Similarly, you also have to choose the right technique or the correct technique of data collection or data analysis. For example, if you are choosing to use observation as a data collection technique, then you must decide whether you want the participants to know that you are observing them or not. Are there any ethical concerns? So on and so forth. You also have to think whether you have a logical hypothesis that can be tested. Does your research design have the basic assumptions that you can test, but actually you may not be able to do so? So often when we design a hypothesis, we should make sure that it is specifically measurable by the data analysis or data collection tool or methods that you are employing. If the hypothesis is not logical, something that you cannot measure, or something that you don't have the capacity to measure, or the knowledge or the theoretical foundation, or you do not have the correct methodological instruments to do so, then there is a basic research design fault. You also have to think about the lack of meaningful interpretation from insufficient statistical analysis. This is a big factor that the early researchers should consider, because often when we do a data analysis, we do it at a surface level because we want to quickly conduct the data analysis, conclude the findings, and publish our research or finish our thesis. Now, if you do not go into the depths of the statistical analysis, you may uh, exclude yourself from finding the depths of a topic that you are exploring, or you may make conclusions which are not based on an in-depth analysis of the topic, which will then lead to the examiners or reviewers asking you counter questions which you will not be able to answer. Often researchers do not want to go into the in-depth of a statistical analysis because they are afraid that what they might find may go against their claims. This is incorrect way of thinking. Even if you find something which does not support your hypothesis, that is still a research finding. You can still highlight it. You can still explain the context in which you found that data, or the way you analyzed it does support or does not support your hypothesis. Finally, you also have to ask yourself that the way you designed your research, did it really address the research gap? Is your hypothesis helping you to answer your research questions? If you have proposed a research gap or research questions at the beginning of your thesis or paper, and towards its conclusion you have not answered it, then it's an incomplete research. When you design a hypothesis, you should always make sure that at the end of the day you are answering the problem or the question you proposed at the beginning of your research. Then there are sampling errors which can also cause or errors in hypothesis testing. For example, let's talk about population specification error. Now, what is an example of that? Let's say you are studying into patterns, or you are trying to study what attracts parents to the clothing apparel for their kids. In this case, are you going to interview both the parents, the dad and the mom, or you are only going to interview the parent who is involved in decision making? In this case, if you interview parents who are not involved in decision making, you are unnecessarily collecting data from people who are not helping you in testing of your hypothesis. Then there could be selection error, where you have only received data from participants who were interested or keen to respond to your survey or your interview. You have to find ways to enhance participation. You have to collect data from your target population or your target sample, making sure that you do not only collect data from people who are keen to participate. Otherwise, there will be gaps in your hypothesis testing. You also have non-response error. Non-response error refers to people who have not been able to respond due to the fact that you were not able to reach out to them, or they were simply not able to provide a response, or they were omitted by error. So a target population or target sample, if they are omitted by error because you missed them, or because you could not identify that they were also part of your research study or research design, then that will also create errors in your hypothesis testing. You have to make sure that the participants or the target sample and the target population, you include a comprehensive size which will help you to answer your research question based on a significant statistical analysis. If your sample size is too small, or not significant enough for you to conclude findings, then of course your examiners or reviewers will question you. Sometimes qualitative studies have smaller sample size, like 30 participants or 10 participants. That is only when they are trying to find an in-depth analysis of the issue. They might have collected a sample size from a larger population before, or their study could be justified by a smaller population. At the end of the day, you have to make sure that the data that you are collecting is from the population that you targeted, and you have adequate representation. That is the word, adequate representation from the sample size. Then we move into type 1 and type 2 errors of hypothesis testing. Now, before we do that, you have to understand there is something called null hypothesis. And what is null hypothesis? Null hypothesis is the counter of the hypothesis. So in hypothesis, of course, we we claim that there is a relationship between the dependent and the independent variable, but in null hypothesis, we say that there is no relationship between the dependent and the independent variable. Null hypothesis is often denoted by the capital letter H with a subscript of 0. So let's take an example of null hypothesis. Let's say your research question is, are teens better at maths than adults? So here your hypothesis will be that age does affect the mathematical ability. And null hypothesis will be the opposite of hypothesis, or you can say the anti-hypothesis, where we say that age actually has no effect on mathematical ability. So the hypothesis is that age affects mathematical ability, and null hypothesis is that age has no effect. Another example where we could say that the research question was, daily does consuming aspirin daily reduce the risk of having a heart attack? In this case, the hypothesis will be that consuming aspirin daily affects the risk of having a heart attack. And the null hypothesis will be consuming aspirin daily does not affect the risk of heart attack, or does not have any impact on the risk of heart attack. So this is the relationship between hypothesis and null hypothesis. Now let's go into understanding what is type 1 and type 2 error. Now what is type 1 error or type 2 error is, let's see. So type 1 error is when you reject the null hypothesis when it is true. Again, this will happen only when there is errors in your hypothesis testing, which could be due to the factors that I've explained below. So if you reject null hypothesis, so normally what researchers do is they propose a hypothesis and they set out to prove that. And the null hypothesis is to counter that hypothesis. Even if your null hypothesis comes out to be true, that is a finding. You have to support it. You should not fudge the data, or you should not reject the data, or you should not ignore the data if the null hypothesis comes out to be true instead of your hypothesis. But if you reject the null hypothesis when it is true, then that is called a type 1 error. And what is type 2 error? Type 2 error is when you accept the null hypothesis when it is false. So there could be another flip side to it, where the researcher, of course, is a ethical researcher, and the researcher finds that based on the data findings, they have found that the null hypothesis was actually true, and they reject the hypothesis and they accept the null hypothesis, and that is the conclusion of their finding, whereas that may not be the case. Now again, this will happen when there are errors in your hypothesis testing due to the factors I have explained before. So here you can see that you will reject the null hypothesis when it is true is, for example, if you say that consuming aspirin daily does not affect the risk of heart attack, or age has no effect on mathematical ability, and you have rejected it, whereas you will find that age actually has no effect on mathematical ability, and anybody will be able to demonstrate an ability to perform math based questions or solve calculations, and age has no effect, but you reject it, and whereas it is true. And similarly, you accept null hypothesis when it is false, where the example would be that consuming aspirin does not have any risk or does not have any impact or affect the risk of heart attack, and you accept it, whereas the opposite could be true. So again, remember that if you address the factors which may cause error in hypothesis testing at the very stage of your research design, and you make sure that you discuss it not only with your supervisors but with your fellow researchers as well, or maybe do a pilot testing, these will reduce the errors that might creep in when you are doing your final or your actual research study. So it's important for you to identify the factors which may impact your study and address it at the very beginning. Also make sure that you explain to the examiner and reviewer how you went about addressing it, so that their concerns are also addressed and they know that what you have found is completely based on an objective or unbiased data collection, data analysis, and the hypothesis that you propose to be true or you reject it has been based on significant statistical analysis. I hope this video was useful to you. If there's something that I missed or something that you think I should have addressed, or you have something to add, please make sure you do that in the comment section. I want all of us to learn from one another, and this is not me trying to project myself as an expert, but for me to also learn from you and your comments. Thank you guys, and see you. Bye.